Good afternoon all. Another electronics video coming to you from the modular shed. So if you want to know how I built this modular shed, yes, I built it completely from scratch. See the link in the description below to my modular shed building channel, Julian's Shednanigans. Okay, let's head inside. And it's nice and warm in here because I've got the heaters on. There they are. Okay, camera in its cradle, like so. So today's video is about options for powering this electronic DC load. Now the two power sockets are on the back, and they are the DC barrel jack and the little micro USB connector. Now I've looked at options for the DC barrel jack. This power supply, 9 volts, 1 amp, which popped a capacitor unfortunately. That came with the DC load, so I'm going to fix this. I found a replacement capacitor. And also in here I've got the T's QD184. Now this thing, you can power it on and set it to 9 volts. That's 45%. So there it is on 9 volts. And that also can be fed into the DC barrel jack. But what if I want to feed this thing with 9 volts, which is halfway between the 6 volt and 12 volt voltage range, but through the USB connector? What if I want to do that? So to get 9 volts into a USB socket like that, I need a quick charge power bank. Now this one has quick charge on that green port, and I also need a quick charge trigger, and I've got various triggers in here, so let's go through them. So I'm going to put this little meter tester on the quick charge output, and you can see that says 5 volts. Now the first of my triggers is this one, which I believe just cycles around the 3 available voltages. Oh, this is turned off, I think. Let's switch it back on. So that's 5 volts, 9 volts where the blue light comes on, and 12 volts also with the blue light on. So this isn't much use, this trigger, because it just cycles around 5 volts, 9 volts and 12 volts. So that's pretty useless. So the next trigger is this one. Let's plug it in. Again, the power bank's turned off. This one you press a button. So 5 volts with the red light, 9 volts with the green light, and 12 volts with the blue light, and it stays, so I can select 9 volts for my DC electronic load. And I could solder some cables to here. I could hack a USB charging cable and feed that into there, but I don't want to hack a cable, so I'm actually going to use this third trigger. Let's try that one. So this trigger is programmable, and it's currently in quick charge 2 mode, I believe, and set to 12 volts. Now this switch, I think, switches between quick charge 2 and quick charge 3 mode. So we'll leave it in quick charge 2, and then I think we've got some up and down buttons. Yeah, this is the down button, so I can have 5 volts. No, the up button. Up button. 9 volts or 12 volts. Oh, that's gone off again. Let's press that. So, and it remembers it. It's got a little memory chip there. So let's bring it down to 9 volts. And it's also got this pass-through socket. So it's going to remember the 9 volts and also let me pass it through into the DC electronic load. Excellent. Let's try it. So here's my power bank. Let's switch that on. That immediately goes to 9 volts, and that's connected into the input on the electronic DC load. And so I have a voltage where I know that this thing's going to be accurate, because it's not accurate at 5 volts. So is that the solution? Well, sort of. The problem with this is the problem I've been having with this power bank all along, which is that the amount of power consumed by the meter and the quick charge trigger, and indeed this electronic DC load with its fans switched off and with the green lights not on, is that it doesn't draw enough current from this power bank to keep it on. And you can see there, while I've been rambling, this thing has just decided to switch off. Now if you can coax the fans to come on this thing with all the green lights, it does actually keep this on. But the off state of this thing, or the default state, is with the fans and the lights off, and then the power bank just shuts down. So that's no good. So how about a bodge solution, which is to plug this light into the other socket, which is the 5 volt socket. That's a 5 volt socket. Well, that hasn't triggered it, so let's switch it on manually. So I've got 9 volts coming out of the quick charge socket, 5 volts coming out of the non-quick charge socket. This has powered up. Now is that small amount of additional load going to keep this unit switched on? Let's ramble for a bit and find out. Ramble, ramble, ramble. Ramble, ramble, ramble. Oh, I don't believe it. So the 5 volt socket stays on and continues to supply 5 volts to the lamp. This indicator is still on, but because the load on the 9 volt socket, or the quick charge socket, is too low, it's actually shut that off. So this thing's far too clever for its own good. It individually senses the current on these two outputs and won't let me override the auto shut off by putting a lamp on the non-quick charge output. Well, now I do have another quick charge power bank, this Orky one. The quick charge on this one is actually the orange socket. The 5 volt is the green. So let's plug this trigger into the orange socket. Oh, this one's upside down. Okay, what happened? Oh, you have to actually press the button on this one. Now, will it go to 9 volts? Yes, it's gone to 9 volts. Will this one sense that enough current is being drawn from this output to actually keep the DC electronic load? No! Switched on, I was going to say. No, it doesn't. So let's try the trick with the lamp. Let's plug the lamp in there. Switch this on. Once again, this has independent quick charge, which can be 5, 9 or 12, and a 5 volt only output, which is the non-quick charge, 2 completely separate boost circuits. So let's see if that works. Does that 5 volts, the current going to this 5 volt LED lamp, keep both outputs switched on? I shall ramble for a bit. Ramble, ramble, ramble. Ramble, ramble, ramble. And now I'll do a little bit of speed up in post. Okay, so that's been half a minute or so, and it does seem like this power bank, when a load is applied to the 5 volt output, actually keeps all outputs switched on. So that's the solution. It's a particular power bank which has quick charge to enable us to get our 9 volts for the electronic DC load, but also a separate output which I can separately load up with a lamp, and it keeps this switched on. That's the answer. Fantastic. So this works, but it's not a very elegant solution, is it? So I was wondering if the quick charge outputs on this power bank, which I made myself, with cheap cells from old cheap batteries. And these two boards, I was wondering if this might work better than this solution, so I guess it's worth a try. Okay, first let's try this board, which only has one output. I assume it's quick charge, and it's got the W332 chip. Let's plug that in and see if it goes. Yes, the green light's come on, so it's gone into quick charge mode. That is saying 9 volts, but will it stay on? Ramble, 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 because it may not detect enough current to keep this output on, because there's not a second socket. Well, there is a USB Type-C power delivery port on it, so I suppose I could trick it like that. Ramble, ramble, ramble. Oh, that's gone off. So that one doesn't work, and tricking it to stay on with power delivery, that's probably even less elegant than the solution I had before. So let's take that out and plug it out into, now, how's this going to work? This one, which is pointing in a different direction. I'm not sure whether we're going to be able to see the voltage on this. Oh, in fact, I can't even get that in there. I'm going to need a USB extension cable. Right, let's try this one. Oh, that's the wrong way around. So I'm going to have to turn it upside down. Now the green lights have come on, so this is definitely in quick charge mode. So I would imagine that's 9 volts. We can have a quick look. Yes, it is 9 volts. The question is, will it stay on? Ramble, ramble, ramble. Ramble, ramble, ramble. No, that has detected that there's not enough current and it has switched off. Now, does this have the ability to support my little light in the 5 volt socket? I can't get it in the 5 volt socket. I think I might need another USB extension lead. It's all getting a bit messy, this, isn't it? Okay, let's switch it on. There's a little button there which I can press. On comes my... Oh, yes, that's not ideal, is it? It's gone into quick charge mode. So this is at 9 volts, but because my guess is that it only has one boost converter, it's had to actually disable the 5 volt socket because it can't produce the 2 voltages at the same time, 9 volts here and 5 volts there. So of course this lamp is now not presenting a load to the board, and so it's only doing the 9 volts on the quick charge socket. It shuts down, there's a quick flash from the 5 volt USB lamp, and we're no further forward. And in any case, this is just a total mess. There must be a more elegant solution. And maybe that solution is power delivery. So there's the USB-C. Now I've got this, which is a nice little short USB-C to C cable. I've got a PD trigger, and I've got a little USB-C monitoring device here. So let's plug it in. This comes on. You can see that I've got 5 volts coming out, but if I press the button on the PD trigger, I can take that up to 9 volts. There's my 9 volts showing on the PD output of this board. This is the one with the W332. Will that 9 volts stay on? Now I don't have the correct trigger board. You can get these trigger boards which, instead of a terminal block output, they actually have a USB type. Oh, well, there we are. There's the answer. They have a USB type A, which I could plug that into. But once again, this port has shut off because it's not seeing enough current being drawn. Let's try USB-C power delivery on the other board. Now the lovely thing about USB-C is I can turn this either way around. So if I turn it that way around so that we can see it, let's plug it in. That comes on. We can see, I hope, that it's 5 volts. I'll press the button to get 9 volts. The green lights come on, showing it's in non 5 volt mode. That's showing 9 volts. Let's just leave that there. Is that going to hang there without touching some metal and exploding everything? And just see if it stays on. Ramble, ramble, ramble. Well, ramble, ramble, ramble. That's been sitting there for about half a minute, and it has stayed on, which is interesting. Now I'm wondering if there's a continuous conversation between the PD trigger and the power delivery port, which keeps it on even in the absence of a current draw. So that's really interesting. If I had the PD trigger, and I've ordered one, would you believe, with a USB Type A socket on it, I could plug my electronic DC load into that. These things can be pre-configured actually to go to the voltage you want. Let's do that. I think what you do is you plug it in while holding the button. Give this a try. Yes, that flickers wildly. Then you set the voltage you want, so I want 9 volts, and then I think you press and hold and the light goes out. Now it's programmed to pull 9 volts immediately. Let's try that. Immediately goes green, that goes green, and if I can put that there without it shorting, and we look at the display, we've got 9 volts. So this thing can immediately demand 9 volts, 9.07, from the PD port, and if that was the right PD trigger board, I could then feed that on to this. Now, isn't that a lot more elegant? Now the chip on this board is round the other side and I can't see it, and I can't remember what it's called. I think it's got a 6 in it. I'll put a little caption down here to say what the chip number is on this board, but you can buy these on eBay. So is that the ultimate solution for powering this electronic DC load, putting 9 volts through a USB micro B socket? Perhaps it is, or maybe there's one more step I can take, and it's this. It's the RAV Power USB Type C with power delivery power bank. And if I plug my PD trigger, which is now programmed to go straight to 9 volts, into this, straight to 9 volts, there's the 9 volts on the little monitor. The question is, will that stay on? Now of course you don't need this voltage monitor once you know that this is working, but if that stays on, then this is my solution. I get another PD trigger with a USB Type A socket. I plug the PD trigger directly into this RAV power bank, and then I plug my electronic DC load into the output. I'm rambling, but this does appear to be staying on, and I think, as far as I remember, this one does stay on. So there must be, like I say, I don't think it's based on current, because there really isn't much. In fact, the ammeter is saying 5 milliamps. I can't imagine that would be enough to keep this thing on. I think it's having a communication with this on a regular basis, saying, are you still there? Yes, I am. Keep the power on. So that, I think, is my solution. This won't stand up, unfortunately, so I'll lay it down. Immediately generates 9 volts when you set this PD trigger to default to 9 volts. My Type A socket will connect to there, and that will bring my electronic DC load on through the USB socket. Yes, I know I can do it through the barrel jack. I just wanted to know if I could do it through the USB socket. And I think that's the solution. So that's it, folks. It can be done. Cheerio.